All right, so today is like the second part of the chain rule lesson. And I don't know why it really goes like this, but today is more trig. So you know sine goes to cosine and cosine goes to negative sine. We'll start with those because we know those already. The derivative, take the derivative of sine x, you get cosine x. Take the derivative of cosine x, and we get negative sine x. We've used that a couple times already, so hopefully that one's familiar to you. And those are by far the most used that we'll use, but the other four trig functions, we need to know those as well. And these are going to be, you just have to know these. There's no, you can derive some of them. In fact, you can derive them all from the first two, but you don't want to spend time rewriting tangent as sine over cosine and then using the quotient rule. That's going to take forever. You want to just have memorized that the derivative of tangent is secant squared of x. And the derivative of cotangent good news is there's a bit of a pattern that starts to develop with trig functions. You probably don't see it yet, but tangent goes to secant, cotangent, any guesses? Cosecant squared, and it's negative. And lastly, the derivative of secant. And again, you could derive this on your own. If you rewrote secant as 1 over cosine, and then use the quotient rule, you would eventually get to secant x tangent x. Derivative of secant is secant x tangent x. What do you think the derivative of cosecant is?
Cosecant x.
What was that?
Cosecant x.
So we swap. We're going to swap both of those. So cosecant and cotangent, and it's negative. So, got to know those. Now, if you know the patterns, you can kind of get by without exactly memorizing those last two, right? Like if you can memorize, you got to know the first four because you use those, and then you can figure out the last two when you need them. So I would put the first four on a, well, it's not the green four, put them on a note card, quiz each other with them, make a quizzes or whatever your favorite study technique is. You got to know those four. The other two you can figure out once you know the pattern. All right, let's do some examples. I'm trying to cut some examples out here. Let's say that f of x equals tangent of the square root of x. Well, I don't really like square roots. We don't handle square roots. We do x's with powers. So let's do x to the 1/2. So chain rule, Tootsie Roll Pop. What comes first? What's the outermost layer? Maybe help to do that. So we'll do tangent first. That's our outermost layer, and then we'll do x to the 1/2 after that. So derivative of tangent is secant squared. Don't change what's on the inside though, right? One derivative at a time. You can't bite the whole Tootsie Roll Pop all at once. Then we'll chain that to the derivative of x to the 1/2, which should be 1/2 x to the negative 1/2. Again, that's fine for a free response. For a multiple choice, that negative exponent would go to the bottom. And on a multiple choice, they might put the square roots back in there to really just make sure you're paying attention. Something like that. I think we can get by with 2 more examples here. F of x equals the square root of the tangent of x. So I like doing these back-to-back examples where it's the same 2 sort of function pieces, square root and tangent, but different ones come first. So let's rewrite this as tangent of x to the 1/2. And again, if you like to think ahead and sort of plan out the path you're going to take, the outermost thing is that power of 1/2, and then the inside thing we'll do next. That's the derivative of tangent. So why don't you try this one? Kind of laid it out for you. All right, so the first thing we said was that power rule of 1/2. So it'll be 1/2 times the inside to the negative 1/2. And the inside doesn't change because we can only do one thing at a time. Right, no biting the whole Tootsie Roll Pop all at once. Break your teeth doing that. Then the derivative of tangent, so now we move to the inside. The derivative of tangent is secant squared of x. And if our argument, if that hadn't been an x, if that had been anything other than x, then we'd have to chain it one more time, right? If that had been x cubed or 5x or anything else, we'd have had one more chain on there. Most of you are cleaning up your algebra stuff, so I mean that's fine for free response, but on a straightforward question like that, it's probably going to be multiple choice, and your answer is not going to look like that. It's going to be secant squared x over 2, and then you can either do tangent of x to the negative 1/2 or to the 1/2, or you could be fancy and write it as the square root of tangent of x. So really starting to put it all together with the different rules from where we started with. So the definitions kind of stand by themselves as separate deals. You've got to know them. But then the rest of these rules start to work together. Power rule, product quotient, chain rule, trig. We start giving you problems that you got to use all of it. You can't just use one rule. You got to recognize all the different rules. All right, let's do one more example. Find the equation of a tangent line to f of x equals x cosine x minus sine x at pi over 2, comma negative 1. Okay, tangent line. Tangent line. That means I need a slope and a point. Well, there's the point. Got that. Slope. Well, slope means derivative. So I need the derivative of this thing at that point, and then I'll have my slope and a point, and it should be good from there. Okay, derivative of this thing. What rule am I going to have to use here? Product rule. This would be one that some people would product rule in place. I'm not so sure I want to do that yet. So let's say f prime equals 1, g prime equals negative sign. Again, that's just for this piece of it. It also gets a little confusing because the name of the function is f, and we just named that thing f. So be careful. Like f prime for my problem isn't 1. F prime for this little sub-problem is 1. Let's see. First times derivative of the second. So negative x sine x plus the other way around. Second times derivative of first. And then this one's kind of tricky because people will forget that, oh yeah, there's more to this. I need to take the derivative of minus sine. That would just be minus cosine of x. So that wasn't part of the product rule, but it was part of the original function, so I'm going to make sure I include that. A little bit of a rigged problem here because the cosine and minus cosine go away. So f prime of pi over 2 equals negative pi over 2 times sine of pi over 2. Again, I think I have all the trig ones memorized, but I usually draw a little picture because that helps me think about what's going on. So pi over 2 is right there. Sine is the y coordinate, so that would be 1. So we just found the slope at x equals pi over 2. Got my slope, got my point, so I think I'm good. Slope, point, so y plus 1 equals negative pi over 2, because that's the slope, times x minus pi over 2. It's kind of an ugly, put it where you can see it there. It's kind of an ugly answer, but it's the final answer, so we don't care that it's ugly. Like, I don't need to clean it up. I don't need to do anything with it. I can just be done with that. All right, so again, putting it all together. The assignment that goes with this is that same page, 136. And it's 43 to 59 odd, 73 to 81 odd. So and all of that really serves as a good review because this isn't just trig stuff. This is trig and chain and quotient, product and power. So I did give you a review sheet, but this is one of those sections where the further we go, the more we've built in review. So that's today's assignment. I'm also going to look at worksheet 4. It's posted and I gave it to you. And we'll look at that in a separate video here.